which is going to be our main thrust source, obviously. In the shield, of course, the GPS plugs into that, and we have our sensors. So right here, these are all the systems that you need, essentially, to have a complete semi-autonomous autopilot system. So when the entire system is integrated onto the airframe, it looks something like this. Now, the GPS system that I'm using, I keep internal because I kind of upgraded the GPS model. This picture here is about 6 months old, and these guys keep coming up with new updates, probably on a 2 to 3 month basis. But as you can see in the front, kind of hole right there, you have the ArduPilot with the shield and everything plugging into that mess of wires. The battery also is going to be located up front. There's a lot of space up there. You see the Z sensor on the side. This is just thermopiles looking up and down. This gives us better calibration data for the X and the Y sensor, which is on top. And then we have our GPS, which we just kind of keep out of the way and with a clear view of the sky. That black box in the middle side there is the servo, and that connects to a control wire, which will move either the aileron or, either the elevator or the rudder for control. In the front, like I mentioned earlier, the pitot tube, essentially we just have a metal tube that's sticking out of the foam somewhere, and it's connected to a little hose and goes to that differential pressure sensor. So this is just going to direct the airstream to the sensor so we can see how fast we're going. I mounted it on the side. I don't know if you guys in the back can see, but I like to put it back here, kind of more resembling a normal pitot tube setup that you'd see on a regular aircraft. But really anything works. You can just kind of push it through the foam up front. Too easy. An awesome creation by the DIY drones community is the ArduPilot config tool. This is a little software script, or I guess an application that was written by the community that allows you to just pull up a Google Maps interface and then just drop waypoints where you want the plane to fly. Really awesome features of this include Google Maps supplying us the data of the ground, the ground level wherever we happen to be at, and then you can specify how much higher you want the plane to be. Some members of the community noticed initially when they were using just GPS coordinates that their planes would kind of fly into the side of mountains, and so this was an issue. They quickly rewrote the code to kind of include this, but this was for this specific setup where you see this bow tie pattern here. The community has, I think every 2 months they throw out a new contest where you can go on there and look at the rules and everything. In this case, you had to fly a certain pattern. I think it was a like 300 or 200 meter square cube that you had to fly in a certain orientation, and then you film the entire thing and you send all your telemetry data and everything off to the website, and they, in this case it was a time trial, so the person that got their UAV around this the fastest won. Cool thing was you could submit it using any plane and any system as long as it was kind of within our category. Obviously I think the Air Force was excluded because they would have won. I think the winner, I want to say he did it in less than a minute. Yeah, this thing was, he like punched the throttle up and it's flying all over the sky. Probably crashed afterwards, I don't know. I didn't make the top 10 list, so anybody that was ahead of me, whatever. Yeah. I was happy that it actually made it around. I was like, oh sweet, this worked. And then it kind of flew into the side of a building and that was the day. Yeah. So telemetry, I mentioned the data that you need to get back down to the ground. Zigbee radios really are ideal for this purpose. These things are tiny. I mean, they're only a couple credit cards thick. It's just a simple board. Here you see the two that I use. The one on top is my ground station one. I have that. I use the RPSMA models because I can attach any antenna I want to them. And it has a SparkFun breakout board on the bottom, which gives me really easy USB connectivity to my computer. So I just run a serial monitor on my computer and just save all the data. The one on the bottom is using a breakout board from LadyAda.com, which gives us the pinouts. And we just push serial data directly from the microcontroller right to that. And you can get that seamless serial link. If you use the right models and the right antennas, you can get about a 12-mile range out of these things. The range is kind of decreased a bit by whatever your video setup happens to be. If you don't have good filtering and everything. We'll talk about that when we get to RF. So I actually came up with the idea that, oh, there goes the shot glass. All right. I actually put the antenna back in here. The nice thing about these foam planes is that you can cut them up. So this plane splits in half. I'll show you in a couple pictures. And I mounted the antenna in the rear boom here, which keeps it nice and separated from the video transmitter up here. It's kind of the best you can do. So when you do that, you get a little bit better range, but you really want to make sure that none of your RF systems conflict with each other. The video feed. I guess I'm really not qualified to talk about this because my video sucked, but I'll show you some better ones. Maybe I can get some faith back. Board cameras are the way to go as far as your actual camera setup. They're very inexpensive. The one I'm flying here is actually only $18 online. I probably could have spent twice as much, you know, forfeited a meal or something, but whatever, it worked. So board cameras, the best place to get them I found is from supercircuits.com. You can find them anywhere from like $200 down to, I think their cheapest model's like $5 or $6. I don't think you'll get amazing quality out of that one, but usually in the $30 to $60 range, you can get really awesome color board cameras that are very lightweight. Obviously, if you lose it, it's not really a big deal if it messes up. Transmitters is more of a problem with these setups. I really want to stress you have to really have a ham radio license to do anything in the RF bands legally. The regular civilian bands that are opened up, if you don't have an FCC license, kind of stink for video feeds because anybody and their grandmother can have like a little security camera outside and it be transmitting wirelessly, and that's really going to mess up with your video feed, especially when you go 3 miles over the hill and you're checking out that X that you kind of never got over. So. As one of my friends says, it's not stalking if you love them, so. But 900 megahertz is probably the best frequency range for this kind of setup if you just want to buy something off the shelf. Rangevideo.com has a $50 transmitter, and then you can buy like a $30 or $40 receiver if you just want a system that you plug and go. And you need a ham radio license to operate that as well, unfortunately. But if you want to roll your own system, I want to recommend the 434 megahertz or 1.25 gigahertz ham radio TV bands. These things are awesome, and you can probably push video, I'm going to guesstimate, well out over 10 miles. The ham radio guys usually send video a couple hundred miles on a regular basis. They'll do like a web chat or whatnot. So if you can just find a way to miniaturize that equipment, which shouldn't be too difficult, keep it in a lightweight package, then you can easily integrate this into your plane. But in the upper right, that is the video setup I'm using. So you can see that the transmitter actually is only a little bit larger than a standard composite jack, so you get a feel for how small it is. And the video camera on the upper left-hand corner, I kind of blew that picture up. I don't know if you can see it. This thing's tiny. It's right here. I mean, this would easily fit in the palm of my hand. And I'm pretty happy with it. It's survived a bunch of crashes. And again, at $20, it's disposable. GPS. So GPS obviously has revolutionized our way of doing things. None of us can read a map anymore, which I guess is good. You don't have to carry that around. But for UAV systems, this is a must-have system. You have got to have a GPS receiver because it's the best way to get positional data. So the systems, the components that you want to look for are going to have a very high update rate or refresh rate, and obviously you want them to be accurate. The GPS component on the left there is a U-Blox chipset mounted on a Helix antenna, and this will give you a 4 or 5 hertz refresh update rate. The one on the right is the one that the ArduPilot system was originally based on. They've moved away from this because it only updated positional data about once a second. But these two, I think the one on the left can receive up to 50 channels, the one on the right up to 20 channels. And ideally, you're looking at positional data from anywhere from ½ meter if you're having a really good day to about 2 meters on average. So, that's all you really need for these UAV systems up in the air. Now, the airframe. This is the best part, I think, because you really get to pick whatever you want to put this guy in. I've seen model airplanes that look like, quite literally and on purpose, flying lawnmowers. I don't know if you can actually modify these to, fly autonomously because they're not going to have the capabilities you want. But you really can take most foam models and modify them with this setup. Foam is the best. You don't want to go with that old balsa stuff wrapped in shrink wrap and everything, because anytime you hit something, it's going to fall apart, and you're going to, be crying on your knees. So yesterday, when we actually put this up, we flew into a tree to land it. I swear that was intentional, okay? Again, all the cabbies kind of came out, and they were staring at us, and buzzed them real quick. The plane's coming in too low. We take it around again. Oh, there's a good tree. I'll just land it into that. So foam is the way to go because you can easily fix it. Gorilla Glue, this is a secret, just between me and you. Gorilla Glue, mix a little bit of water, it foams up. Now this stuff is beautiful because if this plane snaps in half, I can have this ready to go the next day. In fact, I've done this on multiple occasions. The plane literally snaps in half because I did something stupid, like I stepped on it. And a little bit of Gorilla Glue later, yeah, you can see the little seam, and you're like, wow, man, this thing looks like Frankenstein right now, but it flies. So, also, foam's really easy to work with. Obviously, you can just cut it out pretty simply, and you can tape it together. So, the best thing about this plane right here is, if you guys actually come up afterwards, I can show you. The entire thing's held together with Scotch tape. I swear. There's not an ounce of there's no bolt. There's no tape or no glue, and the whole thing's just Scotch taped together. And then I use a little bit of packing tape along the leading edges and to keep the wings snapped in. Works beautifully because, I'm a prototyper, so as soon as I'm done with this, I'm going to tear it apart and try a new payload, try a new setup. Tape's the easiest way to go. You just cut it and pull it off next. So the airframe of choice, ladies and gentlemen, this is the Multiplex Easy Star. This is the plane that you want to have, or at least the kind of the genre of plane you want to have if you're going to roll your own system. Essentially what you have is a pusher motor setup, so we keep the prop to the rear and high of the wing, so we don't have to worry about how this thing's going to land. We don't have to worry about the extra weight of landing gear because it's just going to slide on the ground or smack into the side of a building for recovery. Very effective method, I might add. And remember, foam doesn't really break easily, so as long as your electronics are cushioned, that actually is a recovery technique. I have demonstrated this. The plane is it's perfectly recoverable. It kind of, it gets a little smushed up front, but whatever. So anyways, this is a really nice system because you'll also notice how the wings are kind of bowed up at the tips. This gives it some stability without having to use any electronics in the first place. So it natively wants to kind of keep wings level. It doesn't fly upside down whatsoever. I tried that. It crashed. So anyways, and the best part is that it has a huge payload area. Where you see that black canopy right there, you can just pull that off and throw as much electronics and batteries in it as you want. This, also because of the airfoil, you can really pack a lot of weight on as well. I think my model weighs something like 2 or 3 times as much as the kit is supposed to weigh, and it works fine. I've packed actually about 2 pounds of payload in this thing and somehow made it fly. So there you go. This is what it looks like when you pull it out of the box. It's not going to have anything installed, and it splits right down the middle, which makes it really easy to kind of mount your components. And so the first thing that I do is install the propulsion system. Motors are kind of a big deal with these because obviously it's your only way of getting them up in the air, and you're not really going to use some type of nitro-based or gas-based model airplane engine because they're just kind of big, and I want mine to be quiet. I want this thing overhead at 200 feet, and you're not even going to know it's there because you can't hear it, and you can't see it when it's white and it's up against the clouds and everything. So, anyways, the stock motor that comes with it is actually pretty weak. It's more than enough for the plane when you're just playing with it, but when we're carrying all these extra batteries and all this extra payload, we want something a little stronger. So in model airplane, circles, the best way to go when you want to upgrade any type of electric motor system is to go with a brushless system. This is what I have here. If you go to the DIY Drones website, they've gone out there and they've tried all the different motor setups, and they have concluded that, as market currently states, this is the best one for this airframe. That's a $50 brushless motor that'll turn at several thousand RPM and will take your finger off if you're not careful. We're using a PVC prop, and I have an ESC Electronic speed controller, that's that